Okay, so today's lesson's for Monday, November 7th, 2011. I know that we had initially scheduled to have an exam today. You'll see up here that your homework was to study for an exam on Monday, but I've gone ahead and changed the plans up a little bit. Because you had a sub 3 days last week, I'm not going to give you an exam over anything about circular motion, and instead we're going to go ahead and just begin the new section that we're going to cover on energy, impulse, momentum. And we're going to begin by going over some notes today on impulse and momentum. We're going to finish up the class by doing a poster on the notes that you take, so make sure that you take really good notes as we go through the lesson today. You'll notice that as you walked in, I had some Cornell note paper. You'll want to make sure that you have grabbed a piece of Cornell note paper. Make sure you put your name, the date at the top, your class period, all that information. And under your topic, you're going to go ahead and make your topic impulse and momentum, because that's the topic of our notes today. Now again, if you click on the link to the side, it'll take you to the notes. We'll go ahead and start by going through those notes. So in today's lesson, we're going to be focusing on making sure that you can explain what impulse is, and we're going to want to also make sure that you're able to describe momentum. We're not actually going to get to this third topic, describing angular momentum, because we're going to save that for when we have a little more time later in the year. So the main idea here is that you leave knowing what the equation is for momentum and impulse. Okay, so again, make the topic of your notes impulse and momentum. Okay, so moving on, I'm going to highlight the stuff that I feel is important for you to include in your notes, so make sure that you get that stuff. Here as we start, we're going to talk a little bit about how they drive the equation for impulse. You know that for Newton's second law of motion, that the amount of force we apply actually can change the velocity of an object. So if I push or pull something, that will cause an acceleration in the object. And we can use that equation, that F equals ma equation for Newton's second law, to actually derive the equation for impulse. So what you need to make sure that you have down here is that the left side of that equation at the top, F tangent t equals m delta v, is actually going to be the impulse part of the equation. So right here is what they're referring to. So the impulse is actually equal to a force times the change in time. This is the equation for impulse. You all are taking Cornell notes, so on the left side of your paper you'd want to put what is the equation for impulse, and on the right side you'd go ahead and put impulse is equal to force times the change in time. The other thing that's going to be important for you to write down from the notes that are here, again, I wouldn't write down everything here. This says, it goes on to put it in words what I just said, but you'd want to probably just put the actual equation, like impulse equals force times the change in time. The second thing that you'll be responsible for putting on your paper is that impulse is measured in Newton seconds. So again, because we're taking Cornell notes, on the left side we might want to put what are the units for impulse, and on the right side of the paper you'd want to put that the units for impulse are newtons times seconds. Now down here, the next thing that you'd want to include is going to be, right here it's describing this graph. So on your paper you might want to draw a very basic graph, not so detailed with actual numbers like this one, but I would put force and time, where force is on the y-axis and time is on the x-axis. And what they're trying to tell you here is, it says if the force varies with time, the magnitude of the impulse equals the area under the curve of a force versus time graph. So what they're describing here is this area underneath this curve, all this stuff here underneath the curve. If we were actually to get the area of this, by using equations we have from geometry, we would actually be getting the impulse, because it's a force by time graph. Getting the area would mean we take force times time, which would give us area or impulse. Okay, so these three things are really important that you get down from this first slide. Okay, so let's go ahead and take a look at the next slide. Now for momentum, if we look back at that exact same equation from the first page, right here, force times time is equal to mass times the change in velocity. This involves the change in velocity, which for us is going to be important for momentum, because the equation for momentum is right here. Momentum equals mass times velocity. You'll notice that they have a lowercase p here. They use a lowercase p because they can't use another m, because we're using m for mass. We couldn't say m equals mv, so instead we have a lowercase p. So this is the equation for momentum. Again, Cornell notes, we'd say what is the equation for momentum on the left. On the right, we want to go ahead and write the equation for momentum is P equals m times v. The other thing that you'll have to make sure you note is right here that momentum is measured in kilograms times meters per second. So that is going to be the units. So what are the units for momentum? The units are kilograms times meters per second. So these are the 2 bits of important information off this slide that's important that you have in your notes. Okay, this graph here shows you the velocity and momentum, how they can be plotted with each other. So here you have the momentum of an object based on its velocity. You'll see that it's a linear relationship between the two. So as velocity increases, momentum increases, and that's really the key to this graph. If you'd want to draw a graph, the really important thing would be obviously that you have momentum on the y-axis, you have velocity on the x-axis, and you could show a linear relationship, so a line showing that as you increase velocity, you'd also be increasing momentum. You could also draw a line going down, whereas you, as long as you showed that they actually increased with each other, or decreased with each other. Okay, so the impulse momentum theory is basically going to take these 2 important equations and put them together. So right here, go ahead and highlight what you need to write. That the impulse of an object is equal to the change in its momentum, which is called the impulse momentum theorem. And that equation is right here. So you'll want to write the equation for the impulse momentum theorem is force times the change in time is equal to Pf, which is final momentum, minus Pi, which is initial momentum. So you could imagine an object where it changed its speed, where it would have a momentum initially, but then with its new speed, you would have a final momentum. And that's where you'd actually be able to make this equivalent statement where the impulse would equal the change in momentum for that object. Okay. The other important thing to get off this slide is going to be that the momentum and impulse are vectors. So the sign is going to be important. It's going to tell you directional information about the object in one dimension. So really important that you understand that they are vectors, just like velocity. Okay. Okay, now this problem I'm actually going to skip, but I will identify some of the important information for you, because what I'd like for you to do is, as homework, as a bonus assignment, if you're able to take this home, you'll notice that the next 3 slides, 6, 7, and 8, all deal with the same problem, and all 3 help you kind of answer the problem. But what I'd like for you to do is, if you can take this home and go through the guess method in solving it and answering the question, I'll give you a free grade to make up any 0 that you have, so you'll want to take advantage of this bonus problem and do this at home. Really important, because a lot of you could really use this going into the last week of the 6 weeks to make up any 0 you have. So again, you can go ahead and go to the web page. Like I said, I'm not going to spend class time on this, but if you go through slides 6, 7, and 8, it actually walks you through solving that problem. And I'd like for you to try to finish that by tomorrow if you'd like to make up any grade that you have that's a 0. Okay, so picking up where we left off. So basically the impulse momentum theorem shows that a large impulse can cause a large change in momentum, which is really important that we understand that. So we'll go ahead and highlight that. That's going to be something you have to make sure you have. So a large impulse can cause a large change in momentum. And an important application of this is in cars. So in vehicles, you have car crashes, and one of the key things that people try to do is actually increase the amount of time that you're in that collision of a car crash so that it decreases the amount of force you feel. Because of this equation for impulse, where force times time equals your impulse, if we actually increase the amount of time that you're in the car crash for, it decreases the amount of force that you feel in your body, which is what this is getting to here in this second line right there. Okay, so let's go ahead and take a look at some of the things about, car crashes. If we take a look at an airbag, the airbag increases that time interval during which the force acts, so that decreases the amount of force that you feel. Okay, so the better the airbag, the longer it's gonna cause you to kind of move forward before it stops you. And that cushion right there, that's increased the amount of time that it takes before you stop, is actually going to decrease the amount of force you feel in your body. Okay, so it also spreads that force out over a larger area of your body. So instead of just hitting in one spot, it hits over a larger area, your shoulders and all across your face and your neck, instead of just your face if it were to hit like your forehead onto the steering wheel. The other thing that's interesting that's not actually listed here would be, in a lot of cars now, they actually have crumple zones where if you're coming to a head-on impact with something, the car is made to crumple up and increase the time of the collision so that you feel less force on the car. So they don't make the cars as rigid as they used to because they found that by increasing the time of that collision, you're decreasing the force, which is what we all want because we want less force on our bodies if we were actually to get into a car crash. Okay, that's going to conclude the notes. There's one more page, but it's a little bit more of an extension on this, and you can take a look at that on your own. What we're going to go ahead and do now in class is we're going to go ahead and take the notes that we've just taken and go to the back. You're each going to be given a different color marker, and with your marker you'll be in a group, and I'll cut out some butcher paper for you. And what I'd like for you to do is include any of the important information from our notes into your poster. Make sure that you use your colored markers so that at the end you can write your name on the back, and it'll be really easy for me to grade, who contributed what to this poster. When you're done, you'll just roll it up and we'll tape it closed. You'll put your name and the date on the piece of tape, and you'll turn it in to me before you leave. You do have some homework tonight. You have a cinch reading assignment on impulse and momentum. There's just like all the other cinch assignments, you'll click on this link. It'll take you to the reading assignment. After you log in, you'll answer problems 1 through 5 and submit it to me. If you're not able to do this through the computer at home because you lack internet access or any other reason, then it's going to be important before you leave today that you use one of the computers that we have in the back of the room and actually print that out on your way out today. That way you can still do the assignment even though you don't have the internet at home. Okay, so that concludes today's lesson. If you have any questions, I encourage you to email me. And again, this is the last week of the 6 weeks, so make sure you get all your work turned in on time.